Okay, so now I want to discuss what we can do to make a linked list more efficient by tweaking it so that we can deal with things at the end as quickly as we can deal with things at the front. Now, the downside of using a singly linked list when we want to deal with something at the end is that we have to walk through the entire list until we get to the end. So the first idea might be, hey, let's just store a pointer to the last element in the list. So in addition to having a head, I'll have something called a tail, and that'll be a pointer to the last element in the linked list. Okay, so that is great if you want to go and jump to the end of the linked list. Now you just follow the pointer tail, and there you are. But we do run into an issue if we remove the last element of the linked list at some point. Now I'm not saying how to do that exactly yet, but let's suppose that we did remove that element. And we need to figure out a new tail. Well, in order to figure out the new tail, we have to start all the way back at the beginning again, right? And loop through until we find that this actually should be the new tail. So yeah, we can get, if we just store a tail, we can get there quickly. But if we remove something, it's going to take us a long time to update the tail. Okay? So we actually have to go a little bit further and have arrows going the other way for every single node. So we always had this next arrow for every node. So just to highlight that is a pointer that exists in the node to another node. But we're also going to have previous arrows pointing to the node that comes before. So we have to do a little bit more bookkeeping here and actually store two arrows for every node, one pointing to the node that comes after it and one pointing to the node that comes before it. So here we go with that. And just like the next points to null at the end of the list, so this is actually the next pointer of the last node pointing to null. Prev is actually going to point to null at the beginning, at the first node. Okay. So prev points to null. So here it is. We have this now very symmetric data structure where we have a head and we have all these arrows going to the right called next, and then we have a tail and all these arrows going to the left called prev. And so now, if I think, I'm not going to say exactly how to do it, but let's just bear with me for a moment. If I wanted to jump to the end and then remove it, well, it's very quick to figure out what the new tail should be. The new tail is just what the prev of the thing I removed is. So maintaining those arrows to the previous elements helps me to update very quickly what the new tail should be. Just like before, maintaining pointers to the next elements after a head allowed me to quickly update what the new head should be, right? If I remove the first element there, I make the head into head next, right? So my goal is to shortcut around that first element and make head be head next. And so much the same way, if I want to remove the tail, well, I can make the tail be tail previous. So I can actually point the tail over here to what the tail currently is, but its previous thing. All right? So we have this very nice symmetric data structure, and we should be able to add and remove from the end just as quickly as we add and remove from the beginning. But we have to do a little bit more bookkeeping. So let me break down a little bit what it would take to, let's say, add to the end of a doubly linked list. Okay, so this data structure now is called a doubly linked list. Okay, so to add to the end of a doubly linked list, well, I'm going to need to make a new node. Now let's just be clear on exactly what's in the node again. If I want to define out what's in my linked node class now, well, I still have some object that I'm storing at some appropriate level of generality. And I have a next pointer. just like I did before. But now I also have a previous pointer. So I have to update my linked node object so that it has an additional instance variable, which is a pointer to the previous node. Okay? And what we'll do is we'll set, this is pseudocode here. This is not actual C++ code. But in the constructor, you would make sure to set both the next and the previous to be null by default until we update them to be something else. Okay. So let's try to think what happens when we want to add something to the end of a linked list. So first we're going to make a new node. And what we'll do is, okay, so first we need to set the previous of this to be what's currently the tail, right? So let's say, okay, the node's previous pointer is equal to what's currently the tail. Then I need to say, all right, so let's make a new node. Let's say that I was adding Layla here. So when I instantiate the Layla node, the container's next pointer first points to null, and so does the previous pointer. So that's what happens at that first step there. All right, so next points to null and previous points to null. But now I'm going to say, okay, actually I want you to make the previous point to what the tail currently points to. All right, so now we're going to have this previous arrow, instead of pointing to null, point to what is currently the tail. All right, trying to get all my arrows set up here so you can see them. So let me pan this over a little bit. Okay. All right, so that's the step we're up to so far. Okay, now this is going to be the new tail, so we don't have to do anything to the next. The next should point to null if this is at the end. Okay, but I do need to update. I do need to now say, okay, what used to be the tail's next should point to this new thing now, right? So I'll make this, what used to be the tail, point to this new node that I just made. Okay. And so I'm almost there. Let me make this arrow look a little nicer here. So I'm almost there, but I just need to do a couple more things. Or maybe just one more thing. I need to update the tail. Okay, so actually let me write that step in code. Sorry, let me back up a second. I was saying that I want the next of what's currently the tail to point to this new thing I made, right? So I'll say tail next is equal to this new node that I made. And then finally, I need to add or say that the tail is this new element that I made. Okay, so that's the dance that I play. So tail is now this new element that I made. All right, so I think I got it all. And now if I just move this around and display it slightly differently, you see all the result of doing all these steps. Okay, so this new node that I made has a next that points to null. And after I was finished changing the pointer of the last element before to point to this new one, and then changing this pointer to point to the last element, finally I'm ready to update the tail to be this new element. Okay, so here's the 4 steps. All right. Now, though, there is something I have to worry about a little bit, though, if my linked list is empty. So let's suppose that my linked list is empty. Well, then what I start off with is a head and a tail, which both point to null, right? Because I have an empty list. So my head points to null. And my tail points to null. So if I try to follow these steps, I'm going to end up in kind of a weird scenario where, okay, make the linked node, and then I said the previous is tail, okay, the previous is null. That makes sense. But then I say tail next is node. Oh crap, but tail is a null pointer. I'm going to dereference a null pointer. Okay, so the special case is when the list is empty. Actually, the head and the tail both become pointers to this new node that was made. Okay, so special case, it's actually quite simple. We just make the new node. We don't even need to do anything to the pointers because this is the only element in the list, so there's nothing after it and nothing before it. The next and the previous can remain null. So here's my next, and here's my previous. And what I do is simply say, okay, this is the only node in the list, and so it's actually both the head and the tail point to this node. And so all I have to do is just say head equals node and tail equals node. All right? So yeah, so now it's you know, it's not that much harder than a single linked list, but for all these steps we have to update both a next and a previous, and a head and a tail potentially. Okay. So I'm not going to tell you at this time how to do a remove, because that's actually something I want you to figure out on the next assignment. But you'll have to make similar considerations about special cases and also about updating the pointers of next and previous and the head and the tail. All right? But I will have you do an exercise real quick about how to add something to the beginning of the linked list. I'll have you put the steps in the correct order to do that. All right, so give that a shot, and that's it for this little module.